Hello class, these are our notes for Algebra 1. Today is section 6-8. We are multiplying polynomials and also talking about equivalent quadratic expressions. So the first two here are asking us to multiply. So when it says multiply, I can see here I have this 4x cubed. So this is like how my brain is looking at it. I notice right away I have parentheses. And then I have this term that's in front of my parentheses, that 4x cubed. So there's no plus or minuses there. It's something in front of the parentheses that are being multiplied. So my brain tells me, hey, I need to distribute that. I need to take that 4x cubed and I need to multiply it by everything inside. That's what distributive property is. So let's go ahead and do that. 4x cubed times x squared. Well, the 4 is just a 4, right? But I have an x cubed times an x squared. So hopefully remember from our last chapter that if we have x cubed times x squared, we're thinking about how many factors of x we have altogether. And so we're adding those exponents. We're making it x to the 5th power. Then I have a plus sign. So now I'm doing that second arrow. I'm taking the 4x cubed and I'm multiplying by the 9x. So we can multiply the 4 and the 9. 4 times 9 makes 36. And I have an x cubed times an extra factor of x, and that's going to be x to the 4th power. Then I've got a minus sign, and now I have 4x cubed times 7. So all I can do here is multiply the 4 and the 7, and it is going to be a 28x cubed. So we call this simplifying because we have gotten rid of all of our parentheses, and then we also don't have any like terms yet. So if I look at all my terms, my first one is 5th power, and then 4th power, and then 3rd power, so there aren't any like terms. So I've multiplied it out. You might also hear it called expanded, and we could even say simplify. So there's a lot of different vocabulary for this section. The second problem, problem B, what my brain sees is that I have this set over here of parentheses with 3 terms in it, and then I have an x plus 7 inside. So I need to take this x and I need to multiply it by everything, distribute it to everything in that second group. And then I've also got to go back through and I have to take the 7 and multiply that by everything in the second group. So essentially I'm going to go through and I'm going to be distributing twice. So everything in that first group of parentheses gets distributed to everything in the second is what's happening. All right, I'm going to erase so I can kind of draw in these arrows as we work along. So I'm going to start by multiplying x times x squared. That makes x cubed, plus sign, because there's a plus sign here, x times 9x. Well, x times x is x squared, so I will have a 9x squared. Then I'm going to multiply the x times the negative 3. That's a negative 3x. All right, now I've got to start through and I've done distributing the x. I now need to distribute the 7. So I'm going to multiply 7 times x squared. That's at plus 7x squared. And I could make it go like this. I'm going to do some stuff here. And then I have the 7 times the 9x. Well, 7 times 9 is 63. So we're going to get 63x. And then 7 times negative 3 is a minus 21. So I'm like really working to bring this in here. So one of the other things that we could do is as we multiply, when I start multiplying through with the green arrows by the 7, what I could do is I could be stacking those underneath with their like terms instead. So what I mean by that is when I multiplied and got 7x squared, I could write it underneath the 9x squared instead because I know I'm going to be adding it to the 9x squared. When I got the 63x, I could be writing it underneath the 3x because I'm going to be adding those together. And when I get to the minus 21, I could put that on the end. So this is what it would look like then instead. And I actually really kind of like this method for multiplying big things because now I can go through and I can add up my like terms and columns. And I don't do this for everything, but when I'm multiplying lots of stuff, it simplifies. So now my x cubed is by itself. 9x squared and 7x squared makes a 16x squared. Negative 3x plus 63x makes a plus 60x. And then I have a minus 21. All right, next we're using the box method. So for the box method, I want to draw a box. I am multiplying a binomial, and I call it binomial because x and 5 is two terms. So I'm going to put the x and the 5 on one side. And then on the other side, I have an x and a negative 6. And then what I go through and do is I go through and kind of multiply each little thing at a time. So to find whatever goes in this box, I would multiply x times x. So this is going to be an x squared. For the next box, I would multiply the x times the 5 and get a 5x. Next row, negative 6 times x is negative 6x. And then for my last box, I'm multiplying my constants. Negative 6 times 5 is a negative 30. So this is just a different way of multiplying that doesn't show all this distributing. For some people, this is an easier, more visual way to multiply, and then for other people, it doesn't work. So I want you to be able to use it, but it does not have to be your preferred method. It does not have to be what you do all the time. So now I want to go ahead and write down this expansion. I'm going to start with x squared. So remember we said that we're expanding. You could say that we are multiplying. And you could even say that we are, what's the other word? Simplifying. Because we're getting rid of parentheses and we're putting like terms together. So directions can say a lot of different things. Part of what we need to do is to make sure we understand math vocab. I'm also going to take the negative 6x and the 5x and I'm going to combine those together because they're like terms. Negative 6 plus 5 is a negative 1x. So I could write minus 1x or I could just write minus x. And then I have that negative 30 at the end. So that's my expansion. I'm going to do this for another big one. This is going to require a bigger box. So one of my boxes is going to have 3 parts on one side, the other one 2. So I'm multiplying a trinomial by a binomial. I don't know that it really matters which side things go on. I'm probably completely screwing this up compared to the book, but the way I have space is to draw mine like this. So I'm going to have a 3x and a negative 4. On the other side, I'll have 2x squared, a negative 6x, and 3. So to figure out my first box, 2 times 3 is 6. X times x squared is x cubed. And then I'm going to the left. 2x squared times negative 4 is a negative 8x squared. All right, next row. Negative 6x times 3 is a negative 18x squared. Negative 6 times negative 4 is a positive 24x. So moral of the story here, make sure your boxes are big enough. Mine are not really very big. 3 times 3x is a 9x. And 3 times negative 4 is negative 12. So when I go to write this out, I have my like terms kind of lined up on these diagonals that I'm going to have to make sure I combine. So first we have the, let's see, 6x cubed. So I'm just writing down the stuff that's in the boxes. Negative 18x squared and minus 8x squared makes a minus 26x squared. 9 and 24 makes a 33x. And then my last term is the minus 12. I am totally running out of space here. So let's see if I can write this again. Let's write it over here. So 6x cubed minus 26x squared. Let's see, what did we say? 33x, I think we said. Yeah, 9 and 4 was 33. And minus 12. So another technique for multiplying that works for multiplying two binomials. This is for two binomials. That's what this method is for, is the FOIL method. FOIL method stands for first, outer, inner, and then last. So I'm going to multiply my first terms from each, my outer terms from each, my inner terms from each, and then my last. So by first, I mean the x times the x. So let's go ahead and multiply those. X times x is x squared. And then my outer terms, well, my outer terms would be the x and the 3. They're the farthest apart from each other. So x times a positive 3 is a plus 3x. So if it's positive, we're always writing a plus. Then I want to do my inner terms. So if my outer are the x and the 3, my inner are the negative 1 and the x. So negative 1 times x is a negative 1x, and so I'm going to write minus 1x. And then I want to do the last term from each. So if I'm looking at the x minus 1, my last term is a negative 1. If I'm looking at the x plus 3, my last term is the 3. So we're multiplying these two now. Negative 1 times 3 is a negative 3. So if I multiply them together and it's a negative, I write minus. If I multiply them together and it's a positive, I write plus. That sign thing is always really tricky for people at first. So my middle terms are usually, I won't say always, but usually those are going to be the ones that we want to add together. So I have an x squared. 3x minus 1x is a plus 2x, and then I have a minus 3. So I'm going to do this same pattern, first, outer, inner, last, on part B. So again, this is just another method. So in the first one, my first example, I multiplied by distributing. My second example, I multiplied by using the box method. And now I am multiplying using FOIL, but this one only works for two binomials. So I take the first term of each set of parentheses. So with the 5y plus 8, my first term is 5y. With the y plus 2, my first term is y. So 5y times y would be a 5y squared. And then I want to look at my outer terms. So my outer terms would be the 5y and the 2. So 5y times 2 is 10y, so it's a plus 10y. So remember, what's a positive, we say plus. My inner terms would be the 8y. It's positive, so I write plus 8y. And then for my last terms, I'm going to be multiplying the 8 and the 2. So if I look at each of those parenthesis groups, like here's one set of parentheses, 8 is the last one in that group. If I look at the second set of parentheses, 2 is the last one in the group. So 8 times 2 is 16. It's positive, so I write plus 16. And then once again, my middle terms are the ones that are my like terms. Like terms have the same variable and the same exponent. So I'm going to write 5y squared plus 18y plus 16. So I have what's called equivalent expressions, right? My first, this right here, maybe I should be using a different color. So this 5y plus 8 times y plus 2 is the same as the expanded version. Those are equivalent expressions. So equivalent expressions are the same when you simplify them. So if I simplify the one and I simplify the other and they're identical, that's equivalent expressions. So I'm going to write the same when you simplify them. They have the same terms, they have the same variables when you simplify them. I'm sure there's a more mathy sounding definition, but we wanted to make something that sounded really simple for you. So if you simplify an expression and it's the same as another one, then they're equivalent. So for our last example here, we're going to show that these are equivalent. So when I look at two equations, or two expressions, I need to say expressions because there's no equal sign, right? Only equations have equal signs. So they want me to compare two things. So they want me to compare this x times 18 minus x with this one over here. So clearly the one on the right doesn't have any parentheses. It's already been simplified. So what I'm going to have to do is I'm going to have to work with the one on the left, and I'm going to have to simplify it. And I'm going to be simplifying it by multiplying or distributing, or what was the other word I gave you? Expanding. Okay, so we can't do anything with the second one. It doesn't have any parentheses. We have to focus on the first one, x times 18 minus x. So the way I would get rid of my parentheses is by distributing x times 18, x times minus x. So x times 18 is an 18x. We always put the number in front, minus x times x is x squared. So now I want to check, are they equivalent? Does 18x minus x squared equal? Yep, they do. Check, we've shown that they're equivalent. All we have to do is really show that we're simplifying one of them. B is doing the same thing. We've got something in parentheses here that we need to multiply out and show it's the same as x squared plus 5x plus 6. So this is where it doesn't say what method you have to use. You could use the box method, we could just do a bunch of distributing, or we could do FOIL. So I think for two binomials for students, FOIL tends to be easier. So I'm going to go ahead and multiply my x times my x. This is x squared. My drawback for FOIL is it doesn't always work. If you have like a problem, I'm going to take a break in the middle of this and point it out. So if you have a problem like we did in number 1, where we have like this one had 2 terms, this one had 3 terms, FOIL doesn't work. So I don't want it to be the only thing that you learn. So we have x squared plus my outer are x times 3. It ends up being my distributing pattern as well. So that's a 3x. My inner terms are 2 times x. That's a plus 2x. And then my last are the 2 times 3. That's a 6. I'm always going to take my like terms and add them together. Often that ends up being middle terms. And so I would have x squared plus 5x plus 6. So there we do. It's the same as what we had to start with. So today is all about expanding or multiplying. Lots of different tricks for multiplying. As always, please ask if you need help.